of x equals x plus 1. I tried to do these pretty easily. So, or I tried to pick easy ones. So write a function h whose graph is a vertical stretch of the graph of f by a factor of 5. So I have a times f of x, and a is 5. So I have 5 times f of x. Maybe I should put a little dot in there. All right, so this is going to be 5 times x plus 1. And I get 5x plus 5. And they want us to call it h. So h of x is 5x plus 5. Again, like I said before, it's like if you're starting off at the intersection of Center and University in Provo, and they're like, oh, I live at 500 North, 2nd West. So go up 500, go up 5 blocks, and then go to the left 2 blocks. It's the same thing. This is where I start. This is telling me what to do with it, and this is where I end up. Okay, a lot of times we have more than just one transformation. It's more than just stretching, it's more than just, moving up or down or whatever. So here's one that has a couple. And make sure that you do these in the order that they tell you to, because if you don't, I don't have an example of it right now, but sometimes when you do it out of order, things can get, your answer will be different. Okay, so let the graph of G be a vertical shrink by a factor of 0.25. So first of all, vertical shrink. We've got a times f of x. A is 0.25. So we know that. Followed by, so the second thing is a translation 3 units up. So this is vertical. F of x plus k. 3 units. So k is 3. So first of all, oh, and they give us, might help if they tell us where to start, right? Okay, so f of x equals x. This is just a line. All right, so the first thing we're going to do is we're going to take 0.25 times f of x. Well, f of x is just x, so this is 0.25x. So there's the first one. Second thing we're going to do is we're going to now move it up 3. And so we do that by taking our new function and adding 3 to it. So we've got 0.25x, and we add 3. And they want us to call it g. So g of x equals this equation right here. Okay? All right. Go ahead and try this one. And right now. Okay. So let the graph of G be a translation, 6 units down, followed by a reflection in the x-axis of the absolute value of x. So first of all, we've got a translation, a down. So this is a vertical translation, and k equals -6 because I'm going down, and then followed by a reflection in the x-axis, and that's negative f of x. So first thing I'm going to do is I'm going to take x, okay, that's my function, and I'm going to subtract 6 to it. So that's the first one. Second thing I'm going to do is I'm going to multiply it all through by a negative, because this is my new function, it goes in right here. And so if I multiply everything through by a negative, I end up with negative absolute value of x plus 6. And they want that to be called g. So g of x is negative absolute value of x plus 6. All right, that's what I've got for you. Okay, this right here is really important. I mean, that's all I have for you for the lesson part, but This is all of the transformations that we're doing, and we're going to use these all year. So you're going to need to memorize these. So if you want, you can write them down right here, but there's also a link to a document that has these on them. Print it out, set it by your homework when you're working on it, because you're going to need to know these. All right, they're really important. All right. And finally, here's your homework. It's on big ideas, and Optimus Prime, the old cartoon, says you're about to get hit by a truck. And I know some of you would rather get hit by a truck than do math. I wish you didn't feel that way, but you're going to do great with this. And we will, if you have any questions, you know how to get a hold of me.